Hello everyone, welcome to aravalligeoacademy. Today I'm going to discuss about 5 PYQs. So let's start. First question is, what is characteristic of a disconformity? It always contain volcanic ash deposit. Second option is, it is marked by tilted or folded older rock beneath younger horizontal layer. Third option is, it is separated sedimentary rock from underlying igneous or metamorphic rock. Fourth option is, it represents an erosional surface between sedimentary rock layer that are parallel to each other. So first option, it always contain volcanic ash deposit, not necessary. Second option, it is marked by tilted or folded older rock beneath younger. Okay, that indicates angular unconformity. Third option, it separates sedimentary rocks from underlying igneous or metamorphic rock. It represents non-conformity. And fourth option is, it represents an erosional surface between sedimentary rock layer that are parallel to each other. So this is disconformity. Okay, here is the picture. At first what happened, sediment deposited under the water. This is the deposition layer. Okay, next what happened, due to some tectonic upliftment, it's above the water and become eroded. And third option is, again it deposited under water. So this is the disconformity and this is the disconformity surface. It is undulating surface. Okay. And its example, Mississippi and Jurassic strata of Montana. Okay. This is the undulating disconformity surface. Next question. The diagram representing the grain movement with increasing flow velocity and mean grain size above the river bed is known by which of the following? Mohr diagram, zinc diagram, Joule-Storm diagram, Thomas diagram. So answer is Joule-Storm diagram. See, this is Joule-Storm diagram. It x-axis is size of the particle and y-axis is river velocity. Centimeter per second में दिया है. तो okay, and this is the erosional and this is transported and this is deposited. Okay, so and this line is mean or critical erosion velocity curve. Above it particle eroded and below it particle transported, and this is the mean fall or settling velocity curve. Above it particle transported, below it particle deposited. And okay, and if you draw a line from the 50 centimeter per second velocity, what happened, it crossed the erosion velocity curve in the sand part. That means sand has very mean critical erosion velocity. Then the clay as well as pebble cobble, it has very mean erosion velocity curve. Okay, so next, what is the main difference between tempestite and turbidites? Tempestite form in deep marine settings while turbidite form in shallow marine water. Next, tempestite are caused by storm, turbidite are traction current. Third, turbidite exhibit symmetrical ripple while tempestite do not. Fourth option is, tempestite are poorly sorted, turbidites are well sorted. So tempestite actually it is the deposit which indicates storm. So option 2 is correct. Let's see what is tempestite. Tempestite are storm induced sedimentary deposit formed during the high energy event. Okay, the term tempestite originated from the Latin word tempestus, that means storm. Okay, it is typically found in the environment ranging from delta to deep marine. Okay, Fourth is they are most common in wave dominated deltic system. Fifth one is Thermstite form between fair weather and storm weather wave base, recording event driven sedimentation. C. Thermstite is a storm deposit na, तो Hamuki cross stratification is very popular, very common in Thermstite deposit. So Hamuki cross stratification is a diagnostic feature of many Thermstite deposit. They can also preserve in freshwater lacustrine environment. Thermstite often show graded bedding, shale lags, erosional base. These deposits help construct paleostorm activity and paleo environments. Thermstite are distinct from turbidites in origin, being storm rather than gravity-driven flow. Turbidite is gravity-driven flow and Thermstite is due to storm. See. Okay, this is the passive continental margin where self, slope, rise. We all know this terminology. This is deep marine fan. This is very beautiful picture. Next, see. Okay, what is turbidity deposit or what is turbidity current? So turbidity current is actually when a very dense muddy water interacts with very fresh clean water. So this type of turbidity deposit form. Here you can see the definition, and beds deposited by turbidity current are called turbidites. Okay, each event produces a single bed characterized by decrease in sediment size from the bottom to the top, a feature known as graded bedding. This is the picture, and turbidity current deposits are well explained by Boma sequence. You can check Boma sequence. Okay. Next is which term is recommended to denote a mineral or a rock grain greater than 1 by 16 mm and less than 2 mm in diameter. So greater than 1 by 6 mm and less than 2 mm. Clay, sand, silt and pebble. So this is question for you. You write the answer in the comment box. Fifth question is which of the following sedimentary structure is most commonly associated with tidal environment? Planar cross bedding, shoal mark, placer bedding and graded bedding. Okay, let's see the picture. Here is the picture of flesser, wavy and lenticular. Actually those all are indicate tidal flat deposit or tidal environment. See, when we gradually towards down direction, mud content very high and sand content very less. In the first case you see matrix is very rich in sand and there are some mud streaks, some undulating mud streaks present. Second, almost mud and sand content almost similar, same quantity. In third case you see matrix is very rich in mud and here some lensoidal shape of sand deposit present. So this indicates flesser bedding, this is wavy bedding and this is lenticular bedding and this represent tidal flat. Thank you for watching this video.